Problem 4. Simplify square root of 27 plus square root of 147 plus square root of 300. Okay. Before I do this problem, I want to guide you step by step. So do for one square root. So I will do problem 1, which is to simplify only square root of 192. And also, before we do that, I want to give you a little hint of this. Okay, list of perfect squares from 1 to 400. List of perfect squares. So if you want to solve square root problems, you must understand square root and the perfect squares, how square roots and the perfect squares work. So what they mean by perfect square? Perfect square is what that number came from a number multiplied by itself. To be specific, 1 is a perfect square. Why 1 is a perfect square? Because 1 is same as 1 multiplied by 1. I want to highlight it. Okay, no problem. So 1 is a perfect square because 1 came from 1 times 1. 4 is another perfect square because 4 came from what? 2 times 2. 9 is a perfect square because 9 is what? 3 times 3. So if they say that number is a perfect square, that means what? That number is equal to a number multiplied by itself. So if I take 100, 100 is a perfect square. Why 100 is a perfect square? Because there exists a number multiplied by it. The same number give you 100, and that number is 10. So 10 times 10 is 100. Or if I take 144, 144 is a perfect square. Why? Because 144 is a number multiplied by the same number, and that number is 12. So 12 multiplied by 12 is 144. If I take a 400, 400 is a perfect square because 400 is a number multiplied by the same number, and that number is 20. Okay, you can realize something. So that, okay, we form the perfect squares from counting numbers. Counting numbers are 1, 2, 3, 4, 5, and so on. So you see on the left side here, I have counting numbers. So each counting number multiplied by itself give you another number we called a perfect square. Okay, so if this part is understood, now we go back to the problem. So problem 1, we want to simplify one square root of 192. So if they give you this question in the test, they will not allow you to use a calculator. It's something you can do without a calculator. Even if it allowed you to use a calculator, the answer will not be a decimal, because if you plug 192 in a radical and you check, they will give you a decimal value. But you will see here, for the possible answers, there is no decimal values. Okay, so it has to be a square root. That means you have to know how to simplify it. Okay, so as one square root of 192, the best choice is 8 square root of 3, which is here. Now let's see step by step how they get this. First of all, 192. The first question to ask, is it a perfect square? No, 192, no. If we go back here, there is no perfect square as a 192. We have 169. After that, we have 196. So there is no 192. That means what? We need to break it down. We're going to break it down. Yeah, break it down. Okay, that's going to be the key word we're going to use here. Okay, so we break it down. Yes, we're going to break it down to make it simple. Okay, so to break it down, the thing is this, you ask yourself if you can rewrite 192 as a multiplication of two numbers, give you that. And from the two numbers, 1 will be a perfect square. So here they use a 64 and 3. That means what? Square root of 192 is same as square root of 64, okay, and multiplied by square root of 3. So if you check 3 multiplied by 64 is 192. Okay, so that means what? When you have the value to know that, oh, it's going to be 64 multiplied by 3 or whatever, the first thing to do is to check. If you take a 192, you divide it by 2. Okay, what do you get? That's going to be the first question you're going to ask. Okay, now you take a 192 and you divide by 2, that will give you 96. Okay, but 96 is not a perfect square. There is no perfect square here as a 96. We have 81 and 100. Okay, so that means what? Even we know that 2 multiplied by 96 give you this 192, but it's not helpful. For that, you move to the next counting number, which is going to be 3. You take 192, you divide it by 3. That gives you 64. Okay, and the 64 is a perfect square, and we have it here. Okay, so therefore we can use 3 and the 64, and you have square root of 64 multiplied by square root of 3, and from there, because square root of 64 is a regular 8, so you're going to have 8 square root of 3. Okay, and that gives you 8 square root of 3 as your final answer, because we cannot go further. Yeah, we stop there. So that's the purpose of the perfect square, because when you have a perfect square, the square root of that perfect square give you a regular number, and that regular number is what? Is the counting number they use to find that perfect square. So the counting number they use to find the perfect square 64 is 8. Therefore, square root of 64 give you that regular 8, and the answer will be 8 square root of 3, because we cannot do anything with the square root of 3. Okay, there is another way to solve this problem, which is what? Okay, another perfect square you can find from the two numbers you multiply together before you get 192 is, the 16, which is the other perfect square. So that means what? If you do 16 times 12, that give you 192, and the square root of 16 give you regular 4. Okay, and you have to understand that the square root of 12 is what? Square root of 4 multiplied by square root of 3, because you break it down, the 12 also as a 4 times 3, and that give you now 4 times 2 times radical 3, and you get the same answer. See, so for me, the first part is simple to understand, because if you try to divide by 2, it's that, oh, you divide by 2, but the number you get is not a perfect square, you move to 3. If 3 doesn't work, you move to 4. Okay, so that will help you probably to get the answer before you reach 12. Okay, so practice, makes perfect. So let's see another problem. Okay, problem 2. This time we want to simplify square root of 98. Okay, the first thing to check is 98 a perfect square? No. We have 81. After 81 is 100. 98 is between 81 and 100, and the 98 is not a perfect square. So we need to again break it down. Now, how to break it down? Again, you take 98. The first thing to do is to divide it by 2. You divide 98 by 2, that gives you how much? 49. Okay, so this is telling you that if you take a 49 and you multiply by 2, you will get the 98. Yeah, so division, the inverse operation of this division is a multiplication. So you multiply 2 by 49, that gives you 98. Now, we check. 2 is not a perfect square. We know that. What about 49? Yes, 49 is a perfect square. And then 49 came from what counting number? Okay, 49 came from a 7. Okay, so 7 times 7 is 49. Therefore, this is telling you that you can use square root of 98 as a square root of 49 multiplied by square root of 2. And the square root of 49 is a regular 7. So when you find the square root of a perfect square, that gives you a regular number, and for that you don't need any more the square root. So you have a square root of a square root of 49 is regular 7, and we keep the square root of 2. Therefore, the answer is 7 square root of 2. And because you check with 2 by dividing the number by 2, and that works, you don't need to go further. Okay, so the answer is 7 radical 2. One here. Practice makes perfect. Let's see another problem. Okay, this one is tricky. It's tricky. Even they say factor, they say 2 square root of 120. But you have to understand that this is telling you to simplify, to reduce. Okay, so we have a 2 square root of 120. Understand that this 2 here, which is a regular 2, came from a square root of a number. Square root of what number give you 2? Square root of 4 give you regular 2. Okay, so that 2 is multiplying the square root of 120. So what we'll do here is to again break it down. This is square root of 120. The first thing to do, you take a 120, right? Okay. If you check, there is no perfect square as a 120. Okay. We have a 100, we have a 121. So we don't have that. So what will you do? We're going to divide it by 2. If you do that, that gives you 60. So this is telling you that if you take a 2, you multiply by 60, you get 120. But 2 is not a perfect square. 60 also is not a perfect square. That means what? This is not helpful. Okay, so because it's not helpful with a 2, this time we're going to try to divide it by 3. And if we take 120 divided by 3, you get 40. Okay, so this is telling that if you take a 3, you multiply by 40, you get back the 120. Now, 3 is not a perfect square. 40 is not a perfect square. That means what? It's not helpful. Can we try with another number? 4. Okay. Now, what is 120 divided by 4? 120 divided by 4 is 30. Okay. Even 30 is not a perfect square, but 4 is a perfect square. Therefore, we can use 4 and the 30. That's what we have here. So the 2 multiplied by square root of 120 is same as 2 multiplied by square root of 30 multiplied by square root of 4. Understand that square root of 30 and the square root of 4 together, multiply together, give you the square root of 120. Okay, now what we're gonna do? We have 2 regular, the square root of 30. Okay, we cannot do anything with this. But the square root of 4, we can simplify or reduce it. That gives you what? Regular 2. So if I want to write it down, we have a 2 multiply the square root of 30 multiply by what? A regular 2. And this regular 2 here came from what? Square root of 4. Okay, and the square root of 30 stays like that. Now, we're going to multiply regular to regular. Yeah, regular to regular. That's the way a simplified square root problem works. Okay, so we have a 2 multiplied by 2, regular multiplied by regular, give you what? Another regular, which is going to be here, 4 square root of 30. Okay, the thing is this, we say that 30, we cannot break it down, because if you break it down, just take 30, it's still going to be 2 multiplied by 15. 2 is not a perfect square. 15 is not a perfect square, so not helpful. Or you say, oh, you know what? You're going to be 5 multiplied by 6. 5 is not a perfect square. 6 is not a perfect square. So we're going to leave it like this. Therefore, the answer is 4 root of theory, which is the one we have here. You see, so the number in front of the square root, which is the 2, is multiplying the square root. So when you break it down the square root and you get a regular number, that number in front of the square root will multiply the regular number as we did it here. Now let's do our last problem, which is the challenge problem. Here we have a 3 square root. Okay, but the concept is the same, which is what? You take it one by one and you break it down. One by one and you break it down. So if we take the square root of 27, 27 is not a perfect square, so we need to break it down. If you take a 27 divided by 2, that gives you a decimal. That means what? Doesn't work because we want to get to the answer which is not a decimal. Okay, you take a 27, you divide this time by 3, so 27 divided by 3, that gives you what? 9. The reason we have these two numbers in the square root. So square root of 27 is same as the square root of 9 multiplied by 3. And then from there, if you have square root of 9, so let me write it down. You have square root of 9 multiplied by 3 like this. This is telling you that you have square root of 9 multiplied by square root of 3. And the square root of 9 give you what? A regular 3. That's the reason we have this regular 3 in front of the square root. Okay, and the square root of 3, nothing to do with this, so we leave it like that. Therefore, square root of 27 is a 3 square root of 3. Okay, what about the square root of 147? Same thing. 147 is not a perfect square, so you have to break it down. If you take a 147, you divide by 2, that gives you what? Decimal number, not helpful. You take a 147, you divide it by 3, that gives you 49. Therefore, square root of 147 is same as square root of 49 times 3. Okay, the reason we keep this is what? 49 is a perfect square, so that's helpful. Now, this is telling you that you're gonna again take a square root of 49, okay, and then multiply by square root of 3. Okay, do that, the square root of 49 give you a regular 7, which is this regular 7 here. Multiply now by square root of 3. And again, square root of 3, there is nothing to do with that, so we leave it like that. Okay, almost done, right? Now, the last part, which is to, again, simplify the square root of 300. You will see that 300 is not a perfect square. We have a 400, but we don't have a 300. 300 is not a perfect square. Therefore, what we'll do, then we do the same process. If you take a 300 and divide by 2, that will be what? 150. But 150 is not a perfect square. 3 is not a perfect square. 2 is not a perfect square. Let me repeat that part. If you take a 300, you divide it by 2, you get what? 150. Okay. 2 is not a perfect square. 150 is not a perfect square. That means what? It's going to be another thing. So we need to go further. For that, we divide by 3. Okay, and the 300 divided by 3 give you 100. Wow, wonderful. Look, 100 is a perfect square. So 3 multiplied by 100 give you 300, but 100 is a perfect square. So when you break it down into one of the numbers, it's a perfect square, that is fine. So that's what we are looking for, and we want the highest perfect square because we can find the more perfect square, but the thing is this: when you find the highest perfect square, that's the highest perfect square we can find in 300. So when you find that higher perfect square, that helps you to avoid many steps. That helps you to avoid many steps. Otherwise, you're gonna break it down, 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 break it down. So you're gonna have a many step. Okay, I can do this in another video when I'm gonna take a square root problem, but I will try to use many steps, which is to use different perfect square, so you'll see how the problem will be long to solve. Okay, so this is a quick method. So if we find the highest perfect square, that can help you to avoid many steps. So come back to the problem. We have a 103, but the 100 is a perfect square. So that means what? We're going to have a square root of 100 multiplied by square root of 3. And the square root of 100 is a regular 10. A regular 10. When you find the square root of 100, you get a 10. 10 is without radical is without a square root. So it's going to be regular 10 multiplied by radical 3. Okay, so the critical part is done, or the hard part is done. Now, the rest is what? Is to combine all these radicals or square root. Will break it down. So we're going to combine 3 radical 3, 7 radical 3, 10 radical 3. So having 3 radical 3, 7 radical 3, 10 radical 3, we're going to say that they are like terms. Why they are like terms? Because they have radical 3, radical 3, radical 3 in common. So it's like they will say, oh, 3 bananas plus 7 bananas plus 10 bananas, or 3 students plus 7 students plus 10 students, or 3 kids plus 7 kids plus 10 kids. So the radical 3, 3, 3, 3 is the same for each one. So that's the way you have to understand it. So 3x plus 7x plus 10x. So in total, you have what? 20 radical 3. So you add the numbers you have in front of the radical, and you keep the radical 3. So the number in front of the radical, we call it what? Coefficient. So the coefficient for the first radical here is 3. The coefficient for the next radical is 7. The coefficient of the last radical is 10. When I'm saying radical, understand that I'm saying square root of, square root of, square root of. Okay. So I think this is helpful, but again, feel free to leave any comment. I will be more than happy to again explain it for you. Thank you, and see you in our next video.